Hi everybody, this is the second video of two that I'd like you to watch. It's about the next shortcut rule, which is the product rule. Product, or multiply, meaning if we have the product of two functions, f times g, the derivative of that is going to be, so if y is equal to f of x times g of x, then the derivative is the derivative of f multiplied by g not derived plus f not derived multiplied by the derivative of g. In other words, derive the first, multiply by the second, and then add to that the first multiplied by the derivative of the second. Let's look at some examples. A of t is 5t squared times e to the t. You first have to recognize where f of x is and what g of x is. So there's f and there's g. This is two separate functions, f times g. If I want a prime, or the derivative, I'll derive the first, so 10t multiplied by just the second, e to the t, and then I'll add to that the first, 5t squared, plus the derivative of the second, e to the t. We know that the derivative of e to the t is e to the t. For this second one, keep in mind that in the past, leading up to right now, you've FOILed. Okay, so you've FOILed these. You've multiplied 2t squared by t squared. You've multiplied and then added to that 2t squared times 2, etc. First, outside, inside, last. You don't need to do that anymore. Think of this as f of t. Think of this as g of t. And then we'll derive accordingly. So b prime of t is equal to the derivative of the first. That's 4t minus 9 times the second, t squared plus 2, plus the first, 2t squared minus 9t, times the derivative of the second, 2t, and 2t plus 0 in this case. The derivative of t squared plus 2 is 2t. Now, if you had FOILed first, outside, inside, last, and multiplied that out, then you would have gotten an alternate expression for b of t, which you also could have derived. Absolutely fine if you do it that way. And if you had gotten that alternate expression and derived it, then you would have gotten some derivative which also would have matched this derivative. In other words, we could expand this piece of the derivative. So again, first, outside, inside, last. We could have distributed our 2t and cleaned it up by combining like terms if there was any way to combine like terms, and you would have gotten the exact same or an equivalent expression as you would have gotten up here. Try it. C of t. So C of t is equal to 3t squared plus 5t. There's f, there's g, and so C prime of t is 6t plus 5. There's the derivative of the first. Notice I'm wrapping it as I did above. So 6t plus 5 times 2e to the t plus 3t squared plus 5t times 2e to the t. Now again, take a moment and think about what the derivative of 2e to the t is. You've got a constant 2 being multiplied by e to the t. The derivative then is the constant 2 times the derivative of e to the t, which is e to the t. Now, just for kicks, let's go ahead and expand this one, and we'll check our answer. So I get, again, this is c of t. I'm expanding c of t in this case. So c of t is equal to 6t squared e to the t plus 10t e to the t. Now, if I were to derive that, okay, so again, this is an alternate way to write c of t. I've expanded by distributing 2e to the t. If I were to derive that, then I would get 12t e to the t plus 6t squared e to the t plus 10e to the t plus 10t e to the t. Now, if we combine like terms, 12t e to the t plus 10t e to the t gives us 22t e to the t. And then I've got 6t squared e to the t added to that. Let's see, plus 10 e to the t. Here's my derivative. If I derive it in that fashion, let's see if this matches. Okay, so let's distribute that. I get 12t. So again, this is c prime of t. I'm just expanding this. So 12t e to the t plus 10 e to the t plus, distribute my 2 here, I get 6t squared e to the t plus, that's a 5t, not a 56. So plus 10t e to the t. And if you take a look, there's your 12t e to the t, 10t e to the t for 22t e to the t. There's my 6t squared e to the t. And there's my 10 e to the t. So they match is my point. Now, just to be clear, that this is absolutely fine. You can use the product rule to derive and leave it in this form. I'm absolutely fine with that. You could have also expanded first to get to this point and then derived and get this. I would expect you to clean that up if you were going to derive in that way. They match, which we should expect them to match. All right. Once again, there's f, there's g, so I'm deriving the product of two functions. We're calling this rule, this next shortcut rule, the product rule. D prime of x then is, and you could foil to expand d of x and then derive, but we're just going to use the product rule. So I'm going to derive the first, 6x plus 0, because the derivative of pi is 0, times x to the negative first minus 4e to the x. So notice I'm calling 1 over x, x to the negative first here. So derivative of the first times the second plus the first, 3x squared plus pi, times the derivative of the second, and the derivative of the second is going to be negative x to the negative second minus 4e to the x. When you derive x to the negative first, you get negative x to the negative second. And as we discussed in the last video, and even mentioned here in this video, when I derive a constant times e to the x, the derivative is the constant times e to the x. There's d prime of x. Let's look at, so we're looking at f of x. F of x is, there's my first, there's my second. I want to derive it. Okay, so f prime is going to be negative 3x to the negative fourth times 4 to the x. So there's derivative of the first times the second plus the first, x to the negative third, times the second, 4 to the x, times the natural log of 4. Remember, the derivative of a to the x, the exponential rule, is a to the x ln a. And so there's f prime of x. G of x is e to the 2x. Well, we can think of this as e squared to the x. Okay, e to the 2x is the same as e squared to the x. And so you could also think of this then as a couple different ways you could think about this. You could think of it as e squared to the x, I should say. Okay, or you could think of it as e to the x times e to the x. Okay, because this is, I kind of skipped a step there. This is e times e to the x, and when I'm raising a product to an exponent, I raise both of those terms to that exponent. Now, the reason I'm writing it in this case as e to the x times e to the x is because I want you to see the product rule at work again. So g prime of x is the derivative of the first, e to the x, times the second, e to the x, plus the first, e to the x, times the derivative of the second, e to the x. Well, e to the x times e to the x, we already said, was e to the 2x. And then I'm going to add to that another, in this case we see it's e to the 2x. This is g prime still. Well, e to the 2x plus e to the 2x is 2e to the 2x. And so the derivative of e to the 2x is 2e to the 2x. You're going to get another shortcut rule next week called the chain rule, which will simplify this even further. We'll be able to find this derivative even faster. All right, I have 3 more problems. These have a little more context than the first ones were just go ahead and find the derivative. In this case, we've got a little more context. We want to know where this function y equals negative x, e to the x is increasing. Now, we've started to look at some examples like this using our first rule, our first shortcut rule, the power rule. But big picture, we're asking where is y prime positive? If I want to know where y is increasing, then I'm asking ultimately where is the derivative greater than 0? So we're going to derive first, and then we're going to see if we can determine where that's greater than 0. So y prime is equal to negative 1 e to the x, okay, because there's the derivative of the first times the second, so negative 1 e to the x plus negative x e to the x, okay? So derivative of the first times the second plus the first times the derivative of the second. Now, we can factor out, and I'm going to do this on purpose, we can factor out an e to the x. And when I factor out an e to the x, or actually, I'm sorry, I'm going to factor out a negative e to the x. When I factor out a negative e to the x, I'm left with 1 plus x. Okay, negative e to the x, here's where we're going to bring a little bit of your pre-calculus knowledge back into play, okay? Y equals negative e to the x is always less than 0. Y equals negative e to the x will always be negative because e to the x is always greater than 0, and if I multiply something greater than 0 by negative 1, then I'm less than 0. So that's always less than 0. But I want to know where this entire thing is greater than 0. So this is negative, this first piece is negative. The only way that the whole thing is going to be positive is if this is also negative. So this simplifies the question. Ultimately, we're asking now, where is 1 plus x less than 0? If 1 plus x is less than 0, and we multiply that by negative e to the x, which is always less than 0, then we get something greater than 0. Well, where is 1 plus x less than 0? Subtract 1 from both sides. X is less than negative 1. We now know, we can say that this function here itself is increasing when x is less than negative 1. Now, I'm going to ask you to graph it. Graph this function on your graphing calculator. Zoom it a little bit and confirm using a graph that this is actually true. Is y equals negative x e to the x, does it appear to be increasing when x is less than negative 1? Because that's what the calculus told us. In other words, you should see a local maximum at x equals negative 1. All right, let's look at one more. I've decided we'll just do one more and we'll call it a day. Find the ordered pair, slope, and tangent line to y equals 7 minus 2e to the x where the curve crosses the x-axis. Where the curve crosses the x-axis. So I'm going to say pause it and graph it. Keep in mind that where we cross the x-axis, if a function crosses the x-axis, then y is equal to 0. That color is not great. Y is equal to 0. Okay? So we want to find the ordered pair, the slope, and the tangent line. Well, slope, remember, means y prime. So we need to find y prime of, I'm going to put question mark, and that question mark is where we cross the x-axis. Let's start by finding where we cross the x-axis. This is where the original function now crosses the x-axis. So I'm going to set y equal to 0. 0 is equal to 7 minus 2e to the x. I'll add 2e to the x to both sides. I'll divide by 2. And then, of course, we're going to take the natural log of both sides. So x then is equal to the natural log of 7 over 2. Now, we're going to keep working with exact values throughout the semester, largely working with exact values. So the natural log of 7 over 2 is our input when y is our output. So the ordered pair is somewhere over here. It's at the natural log of 7 over 2, comma 0. So there's the ordered pair. Natural log of 7/2 is our input, 0 is our output. Now, what is the slope? In other words, what's y prime at the natural log of 7/2? Well, first we need to find y prime, and then we need to substitute the natural log of 7/2 in. So y prime is equal to 0 minus, in this case, 2e to the x, which is just negative 2e to the x. And so y prime evaluated at the natural log of 7/2 is negative 2e raised to the natural log of 7/2. Well, e raised to the natural log of 7/2 leaves us just with 7/2. So we've got negative 2 times 7 over 2, which is negative 7. In other words, our slope, y prime evaluated at the point where the function crosses the x-axis, is negative 7. Last but not least, we need the tangent line. Okay? And recall that in order to find a tangent line, we need two things. We need a slope, I'm going to call it m, and we need an ordered pair. The slope is negative 7. The ordered pair is, as we said, natural log of 7/2, comma 0. Put it together, find the equation of the tangent line, and you've got y is equal to m, negative 7, times the quantity x minus the natural log of 7/2. Now, I should point out, why did I just say y? Because this is y minus 0. There's my y value of 0. And I've got this in point slope form, which is absolutely fine. So y minus 0 is equal to negative 7 times the quantity x minus the natural log of 7/2, or just y is equal to negative 7 times the quantity x minus the natural log of 7/2. Find the ordered pair, check, slope, check, and tangent line to y equals 7 minus 2e to the x, where the curve crosses the x-axis. I'm going to encourage you to plot this original function on your graphing calculator. Okay? Check that it is decreasing, and in this case it's going to be decreasing at a rate of negative 7, where we cross the x-axis. Right? And then you might check just to see if that also seems to make sense as far as being your tangent line to the equation at that point. Okay, I'm going to stop there. You are ready now to work through problems dealing with both the shortcut rule for exponential functions and the shortcut rule for the product of two functions.